And good day, everyone. My name is Ian Angelo S. Domingo, and together with Carl Cesar de Guzman and Christian Dave Bison, we are here to discuss the wind turbine. So, what is wind turbine? So, next slide po. Ayan. Ito yung itsura ng wind turbine. Ayan, pansin nyo, um, siyempre, ang wind turbine, meron siyang blade. Ayan, yung tatlong pahaba na nakikita natin dyan sa picture. And yung nasa gitna niya, ang tawag doon is hub. Tapos kapag pinagsama natin yung hub, tapos yung blade, ang tawag naman doon, sa combination na yun is rotor. And yung nasa likod ng rotor, yun yung nacelle. Ayan. So, sa loob ng nacelle, doon sa pangalawang picture, yung merong kulay blue, yan yung sa gawing gitna, yun yung low speed shaft, gearbox, high speed shaft, and generator yung pinakahuli. So next. Ayan. Wind turbine operating principle. Wind turbine is type of renewable energy that harness the power of wind to produce electricity. The basic idea is that wind turbine use rotor with attached blades to collect wind's potential and kinetic energy. Wind turns the blades which spin a shaft that is connected to a generator which result in generating of electricity. A large number of wind turbine is usually called wind farm. Next. So ito yung parts and operating principle ng wind turbine. Makikita natin dyan yung blade itself, yung sinasabi ko kanina, yung rotor. Ayan, ito yung kanina, yung low speed shaft, gearbox, generator, and makikita natin dyan yung controller, and yung brake mostly malapit siya sa rotor. Ayan. Yaw drive, yaw motor, tower, yung pag pinagtatayuan mismo yung parang stand. Ayan. High speed shaft, nacelle, wind vane, anemometer. Ayan. So next. And ito yung iba pang picture para mas makita natin kung paano ba nag-ooperate yung wind turbine. Ayan. Through wind, kaya umiikot yung blades. And kapag umikot yung blades, syempre iikot din yung mga nasa loob niyan. And kapag umikot yan, doon nagpo-produce ng electricity gamit yung mga nandiyan sa picture. Ayan, next. Parts and function. Ayan. Blade. The blade is a part that relates due to the force it catches from the wind. It connected to the low speed shaft via the hub. The low speed shaft is connected to the gearbox, and the gearbox to the generator. Yun nga, sabi ko kanina, connected sila lahat. Kapag umikot yung blade, yun, lahat yan gagana, or lahat yan magpa-function. Once the blade rotates, it causes the rotation of generator, thereby generating electricity. Most wind turbine consists of 3 blades for maximum efficiency. So next. Ayan, blade design. To produce an amount of power, wind turbine blades generally need to be large and tall. It is shaped to generate the maximum power from the wind at the maximum cost. Improvements in the design has produced new wind turbine, which are more compact, quieter, and generates more power for less wind. Its length is around 50 meters, which 107 meter currently the longest from Siemens Gamesa. So yun yung pinakamalaki na blade. And syempre meron tayong iba't ibang blade design kung saan syempre iba-iba rin yung power na ma-generate nun. Kasi may mga design tayo dyan. Yan, next. Ayan, ito yung pinaka mahabang wind turbine. So imagine nyo na lang kung gaano kahaba. Ayun yung tao sa gilid. Parang wala pa siyang 1/4 nung blade, di ba? Ayan, no? Parang langgam lang siya sa blade. So ganyan kalaki or kahaba yung pinaka mahabang blade sa buong mundo. So next. So ito yung blade design. Airfoils is cross-sectional shape of the blades that determine its aerodynamics. So pansin natin merong parang curve sa blade. Ayan. They are key to blade design. This airfoil design allows the blade tips of the wind turbine to move faster than the wind. It is moving, thus generating more power and higher efficiencies. So next. So ito yung mga airfoil design. Ayan. Thin airfoil family for medium blades. Ayan. Tip regional airfoil 95% radius. Primary outboard airfoil 75% radius. Root region airfoil 40% radius. And sa thick airfoil family for large blades, tip region airfoil is 95% radius. Primary outboard airfoil is 75% radius. Root region airfoil is 40%. So next. And blade aerodynamics. Wind turbine blades work by generating two aerodynamic forces, lift and drag. This is due to wind and their airfoils. Lift force is perpendicular to the airflow and it's in the line with blade rotation. Drag force is in the line with apparent wind direction, which is in opposition of the blade motion. Drag increase in proportion to the portal area of an object facing the wind. So, makikita naman sa picture kung paano nag-work yung lift and drag. Ayan. And next. So, ito yung formula sa lift and drag. Ayan. Kung paano ba nag-work yung blade natin. And next. So, blade aerodynamics. Another thing that the airfoil is able to bring is for the blades to attain difference in pressure on both sides. The most curved side, or we may say the convex side, generates low air pressure, while the high pressure air pushes on the less curved side. Or we may say the side slightly concave part. This is actually the reason for blade rotation. So, sabi ko nga kanina, merong iba't ibang design ng blade. Kaya, syempre, iba-iba rin yung pressure and power na ma-generate nila. So, eto makikita natin sa picture, itong lift and drag turbine blades cross section. So ito yung cross section sa may pinataas. So makikita natin dyan yung angle of attack, low pressure and high pressure. So next. Aerodynamics, blade wind orientation. Here's now the question based on the figure illustrating the optimum angle of attack. which part of the blade is leading edge and trailing edge, front and back. So, para masagot yung mga tanong natin, ito yan. Wind orientation. This photo shows the front side and back side as well as the leading edge and trailing edge of the blade. So, ayan, blade design. In addition to its curves design, twist and trap ay tapered blades further enhance its aerodynamics with the combined effect of twisting and tapering the blades along its length. Improves the angle of attack, increasing speed, efficiency, and lift while reducing drag. Next. Number of blades. Here is now the question. Based on the previous slide, what number of blades is best designed in consideration of all the factors in construction and operation of wind turbine? So, sa tingin nyo, ilan yung number of blades na best design? Siyempre sa akin, yung 3. Kasi yun yung mostly na ginagamit sa mga wind turbine. Siyempre, dahil yun yung ginagamit, siyempre yun yung mas effective. Ayan, next. We already know that the rear of the blades is curved more than the front. This body shape causes a pressure differential when the air moves across the blade, which is what causes the blades to move. Because of the obstruction of the blade, air moves at the faster velocity behind the blade than in front of it. This is what the set of rotation of the blades is in motion. Engineer must consider speed and drag in designing the blades to ensure the highest level of efficiency. For example, if too much drag is created by the obstruction, the blades, the power yield will be lot lower. If not enough drag is created, the blades could move too quickly, causing them to break the sound barrier. So next. Number of blades. The rule of thumb are the fewer blades, the better, since there will be less drag and an increase in efficiency. The number of blades increase the torque and reduces the optimum rotation speed. Having fewer blades reduce drag. Ayan, next. Ayan, number of blades. Ito yung one blade. Because of the decreased drag, one blade will be the optimum number when it comes to energy yield. However, one blade could cause the turbine to become unbalanced. And this is not a practical choice for stability of the turbine. So, imagine niyo paano siya iikot kung isa lang siya, di ba? Paano iikot yung blade kung walang malakas na force? Kasi kung iisa lang siya, mahihirapan yung kapag halimbawa mahina yung wind, 'di ba? Imagine niyo lang paano siya iikot, 'di ba? Ayan. Next.
Two-blade. At a first glance, two-bladed turbine seems like the optimal configuration for a wind turbine, perfectly balanced. And with the blade less than a three-bladed turbine, they will generate less drag. So why aren't all turbines made with two blades? It has a trouble in yawing. Yaw is when it head or nacelle turn to face the wind due to an effect called gyroscopic precession. When a two-blade turbine yaw, it creates a wobble as the blades go from the vertical plane to the horizontal plane, which places additional stresses on the mounting bearing, wearing them down faster. Next. more than 3 blades. Any number of blades greater than the 3 would create a greater wind resistance, showing the generation of electricity thus becoming less efficient than 3-blade turbine. Next, 3-blade. For this reason, turbines designed with the blades are the ideal compromise between high energy yield and greater stability and durability of the turbine itself. Next, blade tilting mechanism. According to the wind speed, the relative velocity angle of the wind also changes. A blade tilting mechanism is a sensor called a part of the wind turbine which tilts the blade or guarantees a proper alignment of the blades with the relative velocity, so that its position is always at the optimum angle of attack. Next, nacelle, the housing of the back of the blade which contains the slow speed shaft, gearbox, generator, and other small parts inside it. Next, gearbox, the component which converts the slow rotation of the blade into faster speed. This is needed simply because the rotation of the blade generated from the force of the wind is usually not enough for a generator to achieve the grid quality voltage output. Most generators need to be turned at 1500 RPM or revolution per minute for 50 Hz and 1800 revolution per minute for 60 Hz. In no way it is feasible for turbine blades to move that fast. Next, a common ratio about 90 with the rate 16.7 revolution per minute input from the rotor to 1500 revolution per minute output for the generator. Next, direct drive, gearless. In direct drive turbine, there is no gearbox. The main shaft spins generator directly, causing it to spin the same speed as a turbine blades. Comparing the gear type, the slow rotation and decrease is moving parts of PMDD generator reduces fatigue and stresses on the turbine, resulting to reduce noise and vibration, longer lifetime, and lower cost of maintenance. Next, an important fact is that due to wind inconsistency, the gear type turbines often operate the partial loads. The efficiency of the PMDD generator excels even in this condition because it continues working nearly to nominal values. This design makes suit even the offshore wind application. Next, one main disadvantages of PMDD is that to make up for its slower rotation, more magnets are added to create the required frequency, the power. This increase the diameter of the generator, which make it a larger and often heavier than geared type wind turbine. Another thing is that additional magnets being used is this type is made of the neodymium, which is expensive. Next, the cost and weight of the direct drive turbines have prevented it from presenting major competition to the gearbox turbines until recently. But other expert claims the direct drive technology will eventually become the dominant one, since the gearbox with turbine is it's a maximum efficiency point, while the PMDD generator have the more possibilities for improvements. Next, brake. The brake system is a wind turbine is a protective device coupled with sensor which automatically stop the rotation of the blades whenever it detects activities that could harm the system during operation. Very high wind pass, vital parts not working, maintenance in power lines, and etc. Next, yaw system. Yaw system is a sensor-equipped mechanisms consisting primarily of yaw motor, yaw drives, and others. It its function is to automatically rotate the nozzle on top of the tower so that the sets of blade is facing the wind directly at all times. It detects its proper direction through the electronic information being fed by the wind being located at the back. This ensures that the wind turbine is producing the maximum amount of electric energy. Next, tower. Wind velocity increases at the higher altitude. This means the taller the tower is, greater electricity it can produce. Majority of wind turbines is supported by the conical tubular steel tower with a height of usually 75 to 100 meters or 250 to 370 feet, depending on the blade's diameter. The tallest is still for completion in the mid of 2022, which is 280 meters, to be installed at, at a test center in Western Jutland, Denmark. Next. Ito yung tower blade diameter ratio. Kumbaga parang habang tumatagal is papalaki yung diameter niya ng yun. Next. Ideal location. The best places for wind farms are sa coastal area at the tops of rounded hills, often plains and gaps in mountain places where the wind is strong and reliable. Some are offshore. To be worthwhile, there should be an average wind speed of around 25 km per hour. Next. Parts of function. Ito yung advantages and disadvantages. Yung advantages niya is wind is free. Wind farm need no fuel. Produce no waste or greenhouse gases. The land beneath can usually still be used for farming. A good method of supplying energy to remote areas. Yung disadvantages naman niya is the wind is unpredictable. It changes speed throughout the day and from season to season. Suitable areas for wind farms are often near the coastal area where land is expensive. Can affect television reception on nearby places. Next. Yung largest wind farm. Yung Gansu Wind Farm is meron siyang 7,965 megawatts sa China. And yung Alta Wind Energy Center sa California, USA, meron siyang 1,548 megawatts. Yung Mufandal Wind Farm sa India, meron siyang 1,500 megawatts. Yung Hornesa Project 1 sa UK, meron siyang 1,218 megawatts. Mark Baden Wind Farm sa Sweden, meron siyang 1,120 megawatts. Sa Jaisalmer Wind Park sa India, meron siyang 1,064 megawatts. Next. Gansu Wind Farm. The Gansu Wind Farm project or Geokwan Wind Power Base is a group of the large wind farms under construction in Western Gansu province in China. In 2008, construction began on 750 kV AC power line to carry electricity from the wind farm, and the construction of the wind farms themselves started in August 2009. In November 2010, officials announced the completion of the project first phase, involving the installation of over 3,500 wind turbines with an installed capacity of approximately 5,160 megawatts. It has an estimated cost of 120 billion Chinese yuan or $17.5 billion. That project is being built by more than 20 developers.
Next, Burgos Wind Farm. The 150 megawatts Burgos Wind Farm is the largest wind power project in Southeast Asia located in Burgos, Ilocos Norte, Philippines. The estimated cost for the construction of the wind was 450 million, which was completed in 2015. Located within a 600-hectare site, the facility consists of 50 wind turbines, which each with capacity of 3 megawatts generating electricity to the Luzon grid. Each wind turbine rests on a tabular steel tower as a 75-meter hub height and a 90-meter rotor diameter. Next. Ito yung example ng grid operation. Yung power cable na nanggagaling sa transformer pupunta sa nacelle, and yung nacelle ipupunta niya sa gearbox. Next, hydrogen power plant. Description: a hydrogen power plant is a concept designed for a new widespread source of electricity. Essentially, it is a facility which uses hydrogen to produce electrical energy. A working principle: large tanks of liquid hydrogen will feed into thousands of hydrogen fuel cells. Their fuel cells are solid structures containing an electrolyte fluid and two terminals, much like batteries. The reactants flow into the cell, in this case hydrogen and oxygen. They intermingle with the electrolyte to produce an electrical charge and water as a byproduct. The water flows out another part while the electricity is siphoned off the terminals and held in gigantic multi-ton batteries. The electricity resides in the batteries until it is needed, in which case it is sent out through the local power grid just like any other types of power plant. Battery parts and functions. Electrolyte is a chemical compound that conducts its electricity by changing into ions when melted or dissolved into a solution. It can be a liquid or paste-like substance. Ammonium chloride, NH4Cl, zinc chloride, ZnCl2, potassium hydroxide, KOH, o lithium, tin, phosphorus sulfide, o Li10SnP2S12, sulfuric acid, H2SO4. Anode is the negative or reducing electrode that release electrons to the external circuits and oxidize during the electrochemical reaction. Zinc, metallic, lithium, lead. Cathode is the positive or oxidizing electrode that acquires electrons from the external circuit and reduce during the electrochemical reactions. Example nga niya ay manganese dioxide, carbon, lead, dioxide, copper. Next. Battery schematic diagram. Ito yung example ng schematic diagram. Next, battery construction, kung paano siya nabubuo. Ito ngayon nasa top niya yung metal cap, yung positive. Yung sunod dun yung carbon rod, yung positive electrode. Yung zinc case. negative electrode, yung manganese oxide. Moist paste of ammonium chloride, yung electrolyte, or yung nasa baba niya, yung metal bottom, yung negative. Next, battery, how it works. There are a couple of chemical reactions within the battery. At the anode, the electrode reacts with the electrolyte in a reaction that produces too many free electrons. As a result, these free electrons repel each other and try to go to a place with fewer electrons. Meanwhile, at the cathode, another chemical reactions occurs simultaneously that enables that electrode to accept electrons. In a battery, the only place to go is to the cathode, but the separator keeps the electrons from going straight from the anode to the cathode within the battery. When the circuit is closed, a wire connects to the cathode and the anode. The electrons will be able to get to the cathode. Kung makita natin dito sa picture. Next, chemical reaction in zinc-carbon battery. Anode, zinc, cathode, yung manganese dioxide, carbon is added to increase conductivity. Electrolyte, ammonium or chloride. Yung overall reactions in the cell niya is Zn plus 2MnO2 is equal to ZnO plus Mn2O2. Note the exact mechanism for this complicated and there is still controversy over the exact mechanism. However, the approximate half-cell reactions are anode. Zn is equal to Zn squared plus 2e negative. Cathode into NH4 plus 2MnO2 plus 2e negative is equal to Mn2O3 plus H2O plus 2NH3. Another chemical reactions is the ammonium ion produces two gaseous products. Ito nga yung 2NH4 plus positive 2e negative is equal to 2NH3 plus H2. These products must be absorbed in order to prevent buildup of pressure in the vessel. This occurs by two mechanisms. Ito nga yung ZnCl2 plus 2NH3 is equal to Zn NH3 2Cl2. 2MnO2 plus H2 is equal to Mn2O3 plus H2O. Ito yung example ng hydrogen fuel tank, yung working principle niya. Next, how a fuel cell vehicle works. Una dito yung hydrogen is pumped into the cell through a flow plate. Yung pangalawa, anode, hydrogen molecule split at the anode point where electrons flow out to the device. A platinum catalyst, a metal that causes a chemical reactions, split hydrogen molecules into a positive hydrogen ions and negatively charged electrons. Yung pangatlo, yung PEM o polymer electrolyte membrane. In the polymer electrolyte membrane only allows the positively charged hydrogen ion to pass, forcing the negative electrons along an external circuit. Next, yung pang-4, electricity. The separated electrons are diverted along the external circuit, creating an electrical current. Yung 5, oxygen. Outside oxygen is pumped into the cell through a flow plate. Pang-6, cathode o molecules combine. Another catalyst at the cathode point where electrons enter a device causes the negatively charged electrons and positively charged hydrogen ions to combine with oxygen to form water, o 2 hydrogen molecule plus 1 oxygen molecule is equal to H2O. Yung pang-7 is yung water. Oxygen combines with hydrogen molecules to make water, which exists the cell. Next, fuel cells work like batteries, but they do not run down or need recharging. They produce electricity and heat as long as fuel is supplied. A fuel cell consists of two electrodes, a negative electrode or anode, and a positive electrode or cathode, sandwiched around an electrolyte. A fuel such as hydrogen is fed to the anode and air is fed to the cathode. In a hydrogen fuel cell, a catalyst at the anode separates hydrogen molecules into protons and electrons, which take different paths to the cathode. The electrons go through an external circuit, creating a flow of electricity. The protons migrate through the electrons to produce water and heat. Yung summary nga niya, yung hydrogen atom enter at the anode while oxygen is fed to the cathode. The hydrogen atoms are separated into protons and electrons at the anode with the use of platinum catalyst. The now positively charged proton possessed through polymer electrolyte membrane, also called the proton exchange membrane, heading to the cathode. The polymer electrolyte membrane, or PEM, is a specially treated material that looks something like ordinary kitchen plastic wrap. It only allows positively charged ions to pass into while it blocks the electrons. The freed electrons travel through a wire, creating the electric current. After passing through the circuit at the membrane, accordingly, once again with the aid of platinum as catalyst, the electrons and protons meet of the cathode whereas by hindi ko mabasa. Nakaharang kita. Whereas byproducts. Next. Schematic diagram. Ito ng example ng schematic diagram. Next, why explore it? Fuel cells have several benefits over conventional combustion-based technologies currently used in many power plants and passenger vehicles. Hydrogen is a very efficient fuel source capable of producing more energy per pound or pearl than gasoline. This means that an equal-sized tank of hydrogen fuel would give a vehicle greater range of more power than when filled with gasoline in an internal combustion engine. Fuel cells have much lower emissions than combustion engines. Hydrogen fuel cells emit only water, so there are no carbon dioxide emission and no air pollutants that create smog and cause health problems at the point of operation. Also, fuel cells are quiet during operation as they have fewer moving parts. Why it hasn't gone mainstream? Hydrogen produced through methane. About 95% of the hydrogen used today is produced by a process called steam reforming, separating hydrogen atoms from carbon atoms in methane. This process is expensive and it releases greenhouse gases, which contributes to global warming, thereby canceling out any benefits to the environment. Hydrogen production through water. The other production method is electrolysis, which separates hydrogen from water. The downside is that it's expensive for hydrogen to reach its full potential as an energy source. Scientists need to figure out a way to produce it inexpensively from clean, renewable sources. Cost. The cost of fuel cells can be high given the use of platinum as one of the largest component materials. However, there is work underway to find non-platinum catalyst approaches. Hydrogen storage. Scientists are still struggling with the challenge of how to store hydrogen because it has such a low energy density. Hydrogen needs to be kept under strong compression to the viable fuel source, necessitating strong tanks and heavy-duty fueling lines. As there is currently no mainstream system of storage and distribution for hydrogen fuel, this is a major practical disadvantage. Next is hydrogen leak. Hydrogen leakage can occur during many steps of its production and use. Science magazine reported in June 2003 that hydrogen leakage from widespread use of hydrogen fuel would gobble up ozone faster than CFCs do. Latest development. Long Ridge Energy Generation Project. Touted as a first-of-its-kind power plant in the United States, the Long Ridge Energy Generation Project, a 485 megawatts facility being equipped to run on a mix of natural has a carbon-free hydrogen, is nearing completion at the site of Farmer aluminum smelter on the banks of the Ohio River. The facility first will burn a fuel blend that includes 5% of hydrogen in the General Electric CO class gas turbine. The plant is intended to transition to 100% green hydrogen over the next decade by relying increasingly on renewable energy to power electrolysis machines that split water into its hydrogen and oxygen elements. Next is Siemens Energy. Construction begin on world largest green hydrogen power plant, part of unique base load solar project. Siemens Energy will operate the unique 170 M facilities remote part of France, Guiana, which will provide 10 megawatts of power during the day and 3 megawatts at night. A unique base load renewable project that combines the world's largest hydrogen power plant with a 16 megawatts machine for electrolysis of water, a 3 megawatts fuel cell, 55 megawatts of solar panel, and 20 megawatts to 38 megawatts or batteries has begun construction in France, Guiana. So yun lang po.